All right, so for our first lecture for week 4, we're going to talk about inheritance. So this is one of those other pillars of object-oriented programming. We talked a bit about encapsulation and abstraction already, and those will sort of use those concepts throughout the rest of the semester. But, inheritance is the first of the other two concepts that we're going to talk about this week. So we're going to do inheritance and polymorphism for the full week. I want to start with an example, and I mentioned before in class that it's our examples are kind of dumb, but they're going to give you a sense of what the syntax looks like. And then when we do sort of our project stuff or a little bit bigger programs, you'll see how we can actually use some of these concepts to help us create larger programs. So the sort of example today, and that we'll sort of use for the polymorphism stuff next time as well, is the sort of dog and cat and then the sort of veterinary type a program. So let's say we're hired to write some program, some application for a vet and keep track of their dog and cat patients. Now, it's not going to be anything complicated. We're going to have things like a name and an ID and a few other sort of properties to represent these pets. So being sort of good object-oriented programmers, we know that we should probably write a class for dogs and cats. And of course, you could imagine other classes as well for different types of pets, but we're going to stick to 2 for the moment. So our structure is going to look like this. We're going to have a cat class, a dog class, and then some other class that has main. Right. So I already in Eclipse, I already have sort of that a main class that we're going to use, and it's just empty except for the main method. We will go in and create the cat and dog class in just a second. From a UML diagram perspective, this is what I want. I want 2 classes, dog and cat, and remember that we always put the variables and stuff at the beginning. So we have a name and ID for both the dog and the cat. And then the cat has this extra variable called hairballs. So it might have hairballs, it might not. This is a Boolean, so that would be true or false. The minus next to the variable names, that tells us that those are private. So we're following this abstraction and encapsulation principle by putting these variables together in their appropriate class and then making the variables themselves private, the data for that class private. Then, of course, each one of them has a constructor that sets those variables. So the dog takes in the name and the ID, and it will set those. And the cat takes in name, ID, and whether or not it has hairballs. Then each one has a getter for get name and one for the ID as well. So all these are going to do, they're simple, they're short little functions that just return the name and return the ID. We'll have a function called says. So a dog is going to say woof and a cat's going to say meow. That's sort of the idea of this function. And it's just going to return the string that the dog or the cat says. Then the cat has one additional function called has hairballs, which tells us true or false. Does this cat have hairballs? So it's not a complicated class. We're going to write them right now, and then we're going to sort of talk about it as we go along. We're going to write both classes. One of the things you could probably note right away is that a lot of this is the same. We have the same. Both these classes have names. Both have IDs. Both have get name and get ID and says. That's important. Because, and I say this in CS1 a lot, and you'll hear me say this in CS2 a lot as well. When you find yourself copying code, for example, I could just take dog and copy it and change a few things, and then I have cat. So when you find yourself copying code, there's usually a better way to do it, and that's where inheritance is going to come in. So let's write these sort of as is right now, both of these classes, and then we'll think about sort of what we can do and what Java allows us to do to sort of get around this dog and cat look almost the same sort of situation. So we're going to go to Eclipse. And I already have my little main class here that contains main. So I'm going to create, I guess we'll do, let's say we'll do dog first. So I'm going to create a class. I'm going to call it dog. And it does not need the public static void main. So it does not need that. So it doesn't need to be checked. And so we can hop in here and we have our dog class. So let's start with the variables. That's where we want to start with our class first. So let's make a private. Let's make a private. Let's do the string first. This will be the name. And I will have it be lowercase here. So I have a private name. And we have a private int called ID. So we have our name and our ID. That's all that the dog is going to have. Now let's make the constructor. So remember, we do the data first, and then we put our constructor in. So if you want to do some comments, these are our data fields. Then we have our constructor. So we're going to make this public. Typically, you will make your constructors public, and it has the same name as the class. So it's dog. And then it needs to take in 2 values, because when we build this object, we need to give it a name and an ID. So it's going to take in a string that I'm going to call name and an int that I'm going to call ID. And then we need to set the name that comes in to the name of my data field. Now, I've used the same names here. I have name and ID and ID. So I'm going to use the this keyword. We're actually going to talk a little bit about the this keyword today as well, just in a different context. So I'm going to say this.name, which refers to the name up here, equals name. So you can tell by the highlighting, the sort of cyan color here is corresponding to the data variable, and that the sort of bluish or sort of bluish purple one is corresponding to the parameter name. And I'll say this.id equals ID. And that's the constructor done. And so lastly, we're going to put in our methods. So we have a few of these, but several of them are relatively simple. So let's start with the get name. So it's a public string, so it's going to return a string. It doesn't need to have any parameters or anything. And all we're going to do here is return name. And notice that the highlighting does match up here. It's a cyan and a cyan. I could write return this.name as well. That it works exactly the same way. So either way, again, using this is not necessary, but sometimes you have to make some adjustments in your code. For example, you do have to use this in this situation because the names are the same. All right, we'll write the public int called get ID, and we'll just return this.id, or we could just put ID. And I want to write a says as well. So say public string says. What does this dog say? So we're just going to return, I'm going to return a string that says woof. Easy enough. So this doesn't do the printing. That's something that I want you to keep in mind. This does not actually print anything. It just returns a string that says woof. For the last method, and I don't remember, I don't think this one was in the UML diagram, but I do want to add it. It's the toString. Remember what toString does? Talked about this last week. If you write a method called toString, so it needs to be public string toString. We always start with a string. Here I'm just going to say string s and make sure that we return that string. And then in here, I can say s equals string.format, and I can put whatever I want to, exactly the same formatting as with a printf. So let's say I want to put the dog's name or the character's name, or sort of whatever this pet's name. I'll do a %s, and then I'm going to put parentheses around another %s, and then undo line. So this is going to print the name and the ID. Actually, we want the %d here. The ID is an int, so we'll use a %d. So we're going to print out the name first. So it'll be, whatever, spot. And then the ID being whatever, like 10 or something. So that's what this will do. So this doesn't do the printing. This just returns the string. It's exactly the same as says, but toString is sort of special in a different way. So we'll mess around with that in a few minutes. I'm going to just copy this. I'm going to take this, and I'm going to take all the stuff inside. So I'm not going to take the sort of public class dog stuff, but I'm going to take all this stuff inside, and I'm literally just going to copy it. So I did a Control-C, and we're going to create a new class. And this is going to be the cat class. Let's see. That should be here. Not quite. Save that. Close that. Delete this one. It's sort of half created, and see if we can do that again. So I'm going to create a new class, and I'm going to name this cat. There we go. So now we got it. And then I'm going to paste all of this in here. Now, clearly there's a few things I need to change, right? For the constructor, it needs to be cat instead of dog. For the says, this should be the meow. The toString is probably fine. It's going to print out the name of the cat and the ID. That should be fine. The only other thing we need to add is that other variable. Remember we had that has hairballs. So we make a private Boolean called has hair. And that needs to come in the constructor as well. So this will be a Boolean has hairballs, and then and then we'll set that. So has hairballs equal this dot has hairballs equals has hairballs. Okay. So that sets up the constructor. The data fields are correct. We need one more getter. So I'm going to throw another getter in here, and this will be the public Boolean has hairballs. And all it's going to do is return has hairballs. So it's just our other getter. So it didn't take a lot of changing to get the cat sort of where it needs to be. But clearly that means that cat and dog, I'll reopen dog again. Cat and dog are almost identical. Cat has a little bit of different stuff, but they almost have exactly the same code. Clearly the copy paste thing worked. Inheritance, this idea of inheritance, is going to let us reuse code that we've already written. It'll make this dog and cat class actually very small. So over the course of sort of the rest of the lecture today, we're going to be changing this from the way it's set up now to a way that uses some inheritance. Now, if I go to main, I can create a cat, and I call it C, and this is a new cat. And we have to put in a name, a string name. So I don't know, put in spots and an ID. Maybe the ID, the number is 10 or something, and maybe it's true for hairballs. And we can create a dog. Create a dog D. This is a new dog, and maybe the dog's name is Rover, and its ID is 12 or something. That only takes 2 because there's no hairball stuff. And then, we can print stuff out. So maybe I want to print out just the, actually, let's do a print line. And I'm just going to print out C. So that should print out the cat. This uses the toString. This is the same as me writing this in printf. I can do here, and I can say, write it as a string and put a new line. And I want to write the dog like this. This will print out the same thing. It's going to use the 2 strings from this. So here's these 2. So that's just printing out the object itself. We can do that because we already wrote the toString. So if you forgot sort of what toString is, take a look at the lecture slides from last week. All right, so everything here seems to work. We can set up these sort of dogs and cats anyway, and we can print stuff out about them, and we can sort of continue on and sort of writing whatever our application is supposed to do. On the slides, and we've sort of written these up here, but on the slides, I do have that sort of full code. They both have the toString, they got the meow and the woof and all that stuff. And I just sort of highlight here that, okay, we have the data, we've got the constructor, and we have all of the methods. And like I said, they're mostly the same. And that's sort of the point of sort of showing these side by side is that, yeah, there's a couple differences, but for the most part, it's the same code in here. So this is sort of what could represent like a main class. I'm not going to write this whole thing out, but you can imagine creating an array of dogs. So you have a bunch of dogs and you have a bunch of cats, and then you can go over and sort of loop over each dog and print stuff out and sort of see what they say. So if we go back in here to main, maybe I want to say something like, I print out the dog, and then I can say says and another string. And so I print out dog and then d dot says, for instance. And it should give Rover ID 12 or the sort of 12 in parentheses, and then it'll say says woof. Now I have some new lines and stuff in there, so we can always mess around with exact formatting, but that's sort of the idea. That's the idea of this. We can always check, does the cat have hairballs or not, because we have that method to check. It returns a true or false, has hairballs. So we could check if C dot has hairballs, then we could print something else out. So there's a whole bunch of stuff we can do, and some of it is sort of shown here. So for the cat, it prints out what the cat says and some of the info about it, and then it says if C dot has hairballs, print out clears throat. So that's the idea of how we can use this. The sort of code that you see here, if you put this into your main, you'll see something that looks like this. So I mentioned that repeated code. It is an issue, because what happens if we need to add another pet? We have to copy. We could copy and paste, or we could just write all the same code again, or a lot of the same code, and then make the little changes we need to add a pet, to add a new pet. So most of that data is the same. Most of the methods in dog and cat are the same. Creating cat from dog is easy. That's what we did. We just copy and paste it. So the thing to remember about object-oriented programming is that part of the whole reason to do it, part of the paradigm itself, is code reuse. We don't want to copy and paste code everywhere. In fact, we want to write as little code as possible, depending on the language we're using. We want to write as little code as possible to get it to do what we want, because the more code you write, the more chances that you'll make a mistake. So the code does work, but there's lots of duplication. So inheritance is one of these OOP concepts that lets us create a general class. Oftentimes you'll hear me call it a superclass or a parent class that share code to other classes, oftentimes called a subclass or a child class. And then you take that subclass or that child class and you specialize it as needed. So the superclass is most often general, and the subclasses are more specific. And this idea of general and more specific is all over object-oriented programming. And so we're going to be dealing with that a lot. What does it mean to go from specific to more general, or general to more specific? This lets us reuse code again. We start with the superclass that contains data and methods that would be shared among all of the child classes. That's the point. We share data and methods among the child classes. So any of those subclasses, any of those child classes inherit and can use any of the methods or the variables defined in the base class. I'm going to show you a UML diagram that will hopefully have this make sense. So we're going to make another class called pet. Pet is more generic than dog and cat. And so all of that generic stuff, right? Every pet is going to have a name. Every pet is going to have an ID. So it's generic. It's just this generic stuff that we have that can go into a superclass, a parent class. We have the constructor as well. We have the get name, because that was the same in both dog and cat. We have the ID. And I'm going to put says in there as well. I do that for a very specific reason that we'll see later on. And we'll talk about it when we actually code this up as well. So that generic stuff, the things that were copied between dog and cat, are now in a separate class called pet. And then we write our dog and cat class. And we connect, in the UML diagram anyway, we connect with arrows. So I'm saying that dog is a pet and cat is a pet. Because dog is a pet and cat is a pet, dog can use and has access to anything that's up here. You follow the arrow back up, it has access to everything in pet. So the dog will have a name and it will have an ID. The dog will have a get name and a get ID and a says. In fact, all I need to have in the dog class is its constructor. Now there's a little bit of syntax I'm going to use that we'll talk about in the near future, so later in this lecture. It has to do with sort of stuff we have to do in the constructor. So we're gonna sort of talk about some of these concepts. The cat has some additional stuff. Not every pet will have hairballs. So the cat gets that specifically. That's a sort of specialized thing that the cat has. Same thing with the has hairballs method. The cat will have its own method that the normal pet class does not have. So that's what I mean by general for the pet and more specific for the cat. The cat has a few extra things that we have to deal with. The dog is pretty much just a generic pet, sort of according to the way we've written this. So we are going to code this up. We're going to add this pet class here in a second. We have a new keyword that does this so that we can define this relationship. Essentially, the thing that would sort of create these arrows. That's the extends keyword. So in Java, we can say that dog extends pet. So classes can be derived from other classes, so they can use their fields and methods using the extends keyword. So we start with the more general superclass, and then every subclass extends the superclass. They inherit, the subclass, the child class, inherits any public or protected methods or variables. That's a key right there. We're going to have to change a few things in our code that we're going to write. So let's go back to Eclipse and let's actually do this. So let's make a pet class. So make a new class. I'm going to call it pet. So I have this pet class, and the stuff that we put in dog was pretty much what we needed. We needed the name and the ID. We'll have to mess with the constructor a little bit. And then we're going to put in all of this stuff from dog. So I'm just going to take the stuff from dog again. That was the sort of generic stuff. And I'm going to paste it right in here. And then we'll make a couple of changes. So the constructor definitely needs to be pet instead of dog. Get name is fine. Get ID is fine. What does a generic pet say? I don't really know. So we'll think about that a little bit later. And I'm going to keep the toString here. So I'm going to show you what happens when you try to use it as well. Save. There we go. Dog itself, when I create this inheritance relationship, I'm going to type extends pet. Notice it immediately, it gave me an error on the constructor. This is something we're going to have to fix. But now I don't need my name and the ID because pet already has it. So I'm going to get rid of the data fields here. Pet already has a get name, get ID, and says and toString. So I'm going to get rid of all these as well. Because remember I said it inherits that data and it inherits the methods. But only the data and methods that are, format on this, there we go. Only the data and methods that are public or protected. This is a new visibility, something we haven't really talked about before. I sort of mentioned it previously, that that there's this sort of visibility that we'll talk about later. We had public, private, protected, and then package private. This is a situation where we would use protected. Instead of private for the variables, we would use protected. Protected means you cannot access it from outside of this class unless you inherit from this class, unless you extend pet. So dog has access to the protected and the public things in pet because dog extends pet. If I had the private here, I'm going to change name back to private. If we look in dog, name gets an error. I hover over name, it says the field pet.name is not visible. So if name is private, the subclass or the child class can't access it. So that's why we want to make it protected. So when you're working on your code, you're working on sort of some OOP stuff, your default for any data should be as restrictive as possible. You should just automatically make any data private. And then later on, when you realize, oh, I actually need that for a subclass, then go back and make it protected. So that's the way I want you to do this. I want you to think, all right, I have some data. It needs to be private. Later on, if I need it to be less restrictive, so if I need a subclass to access it, then go back and make it protected. Your data in something like Java, like what we're doing, should not be public. All right, so dog is actually very simple, but we get this error here, and the constructor error is going to sound kind of weird. It says implicit super constructor pet is undefined, must explicitly invoke another constructor. That sounds kind of weird. We're going to talk about why that happens, but I'm going to show you the fix. The fix is super, and then we're going to send name and ID. And that fixes it. This works now. Super is always the first. You always do the first line in your constructor of a child class must be super. Super is a call to the pet constructor. So the pet constructor needs name and ID. So I'm putting in the name and the ID that comes into my dog constructor. So it's basically just passing it through up to pet. Super means I'm following my extends and I'm calling the constructor of pet. That's how you can think of it. This must happen. We're going to talk a bit more about super a little bit later in the lecture right now. So for cat, we do exactly the same thing. So for cat, I'm going to say extends pet. I don't need the name and ID anymore. I should still have the hairballs setting in here, but I can use super name ID. I still want to set the hairballs because that's a special thing that's part of cat. So pet doesn't set it, so we need to set it here. And then I can get rid of everything else. I can get rid of everything but that has hairballs, because that's one of our special things. So cat becomes much less code. Dog is way less code, and pet is where most of the things are. Now, think about what this means for a new pet that I need to add. Maybe I wanted to add like a parrot or something as a new pet. I could just start like I did with dog, create parrot, extends pet, make a constructor, and then do something special. If I need anything special with it, then add a couple special things like I do with cat, and then I'm done. Way less code for me to write because I had this generic class already ready to go. So that's the basic idea of inheritance. You use the extends keyword, and then you get access to all of the stuff in this class. It just is a little bit more complex in the constructor. Make sure that you call super so that you're calling the constructor of your super class, of the class that you're extending. So both dog and cat do that. If we run main, now we get something a little bit weird here. So we're still creating a new cat and a new dog, and we still get the name and the ID and all that. But notice what it says the dog says. Question marks. we're calling dog, so there are D dot says. Well, dog doesn't have a says. So what says is it using? Well, it's just going up and looking at pet at that point. It says dog doesn't have a says. Does pet have a says? Yes, it does. Use that one. So that's what it's doing. That's why we get the question marks here. But says doesn't really make a lot of sense here, because what does a generic pet say? I don't know. So we should probably have a says in dog as well. So we're going to do that in just a second. All right, so I show some of that code. In this code here, I leave these as private because we don't necessarily have to have them protected for the stuff that we wrote. But you can see the sort of idea. You can see pet.java here, and you can see dog. And then I sort of mentioned this, because dog extends pet, it has access to get name, get ID, toString, and says. So we can use any of those methods when we have a dog, because they extend pet, and these all methods are all public. Same thing for cat, but now we have that little bit of extra stuff. We have the super in there, but we deal with the hairball stuff as well. All right. This is what would sort of be in your main. We can mess around with the cat and see a few things with that. But if we did a says here, we would get the question marks. That's something that we are going to fix in just a moment. All right, let's talk about that super keyword. So super is similar to this keyword. But super refers to the super class. Remember, this refers to the class that you currently are. So when I say this.name, I'm referring to the name that I am. But super will refer to something in the super class, or the parent class. The keyword is used in two ways. To call the superclass constructor. That's exactly what you saw in both dog and cat in those constructors. You have to do that. Super is automatically called. It has to be the first line in any constructor you write where you extend another class. Or it can refer to a superclass variable or method. In our blackjack game, we will also use super in this way. So you will see it in sort of both ways. We're going to call like a super.toString when we do stuff. So super can be used in two ways: call a superclass constructor or refer to a superclass method or variable. So if you specifically want to refer to the pet version of something, you can use super dot and then that, whatever that name is, that method or that variable. All right. So unlike the properties, so the data fields and the methods, a superclass's constructor is not inherited. That's why we had to write our own dog constructor. The pet constructor is not inherited. Even though it's public, it's not inherited like the rest of these. It can only be invoked from the subclass's constructor using the super keyword. So the only way to get access to the pet constructor is to do exactly this. Call super like a function, and that calls the constructor, in this case, of pet. If you don't explicitly use the keyword super as the first line in your subclass constructor, so in our first line of our dog constructor, then Java automatically invokes it. Let me show you what that means. If I don't have super here, if I take this away, I get an error because Java automatically does this. Java automatically inserts this in. But this is trying to call the super with no arguments. Pet does not have a constructor with no arguments. It has a constructor with 2 arguments. That's why we get the error, because Java is automatically putting this in. So if you don't put super in, Java puts it in. It puts it in for you, and then if you're not expecting it, you might get an error. So it automatically does it for you. But because we have a constructor that takes 2 arguments, we need to manually put it in. That is a very, very important note, and something that we're going to do a couple of little examples on, because this is super important, and this happens in any object-oriented programming language. You have this idea of, it's called constructor chaining. which we're going to get to sort of more as we go through this lecture and next time as well. So you must have super. It's always the first thing that is called in a subclass. Is in a subclass constructor is the super keyword. Okay, so let's do a quick example. A quick little exercise. So I got two classes here. And grab a pen. So I have two classes. I have this super class, and I have this subclass that extends super. So if you were to draw this out, we would have a class up here. This would be super. This would be the super class. PER. And then we'd have an arrow going from a subclass to a superclass. So the sort of the picture looks like this. And one of the things that I'm going to recommend doing, especially once we get to more of this sort of chaining idea and some of the polymorphism stuff, I'm going to recommend that you draw out little sort of diagrams like this, because they can be really helpful in figuring out the relationship between classes. So we've got sub that extends super, and we have a superclass. Now, here I just put main inside the subclass. It doesn't really matter. You can think of this in another class. But the only thing that main does when we run this program is creates a new subclass object. So it's going to create a new one of these. It's calling the no arguments. So this is the no argument constructor. So that is this one right here. So we're going to call that constructor. In this constructor, so this is a constructor as well. We have two constructors here, one that takes no arguments, one that takes a string. If the first line is not super, no argument super constructor is automatically called. You might wonder, well, why isn't it put in here? Say that in just a second. So if we do the trace, we're right here. We create a new sub. We're going into the no argument constructor. That brings us up here, and that brings us to this line. This might look kind of weird. Why am I using this as a function? This was always like this dot and then something else. But in this case, I'm just sending in this as a function, and I'm putting in an empty string. What is that? This is the other way to use this. This is calling another constructor. It's calling another constructor in sub. When I call this, it goes down into this one. So in any constructor, in any class, the first line must be either a call to another constructor within the same class, which is what this does, or a call to super. Those are your only two options. So if we follow this trace, so we're doing our sub with no arguments, come up here. We're calling this with an empty string. So that's going to be calling this constructor, because this constructor takes a string. Then we automatically call super. Java puts that in automatically for us. And we come up here, the super with no arguments, and we print super. Then we're done with that constructor. And so we come back down and we print sub that takes a string. We finish this constructor. So that means we've finished the call to this, and we print sub, and then we're done. That is an example of what is called constructor chaining. Notice what actually happened first. The first thing to happen when I created a new subclass was to print out the superclass stuff in the constructor. And then we printed out this one. And finally, we printed out this one. So being able to do these traces and sort of understand the flow of the program is very important. You'll be doing this sort of thing on our sort of upcoming exams and quizzes as well. you will be doing this sort of trace for some code. So get used to thinking about what happens when you create, say, an object, what constructors it goes into, and how this super stuff works. We'll have plenty more examples. You will see this in action, not only in some of the examples we have for class, but also in some of the project stuff as well. So that idea is called constructor chaining. So a constructor may invoke an overloaded constructor, so a second constructor in the same class using this, which is exactly what you just saw, or it can invoke the super. This must be the first line of any constructor in any class you write, either a call to a different constructor in the same class or a call to super. I am choosing my words very carefully. I say this has to be the first line of any constructor that you write in any class, not just a subclass. Let's go back to the code really fast. If I go back to pet, I don't have a call to super, but remember, Java puts one in. It will automatically put one in. It'll put the one with no arguments. This still works. There's no error from me doing this because Java does this. Any class you write technically has this if you don't put it yourself. It's part of the way Java works. And potentially later on in the semester, when we get to some of the sort of little bit more advanced stuff, we will talk about that because it is an important concept. It's the reason why things like a toString work the way they work. So there is some really cool stuff that sort of goes along with it. But yes, any class you write must have either a call to super or a call to this as the first line in its constructor. All right. If none of them is invoked explicitly, so if you don't put that in there, the compiler puts it in as the first statement. So the compiler, like I said, it does it for you, meaning that the superclass constructor is always invoked. You can never have a situation where you do not invoke the superclass's constructor. So if you create an instance of a class, it invokes all of the superclasses constructors along their inheritance chain. We're going to talk more about constructor chaining. We're going to do more and more sort of exercises related to it. But this concept is known as constructor chaining. You will hit constructors from all of your superclasses. So the intuition here, the reason sort of why this happens, is you always want to set up the more general class before initializing any of the specialized classes, because you want to make sure the general is all configured before the specialized gets configured. So in our code, in cat, pet gets set up first. That's what this call is doing. It's setting up the pet constructor. Pet gets set up first, and then the rest of cat gets set up. So we're setting up the general, and then later we'll set up the specific. That's what you can think of in terms of sort of what's physically happening, or sort of the intuition of what is happening. Okay, let's do another trace. So I'm going to show you where main is. It is right here. It's in this faculty class. Again, this could be somewhere else. This could be in some other class, but I just put it in here so that we can have sort of one sort of set of sort of code here. So there's three classes here. There is faculty, there is employee, and there is person. So faculty is the most specific, then employee, and then person is the most general. So faculty extends employee, employee extends person, and then person is sort of our top level. So if we drew this out, we would have person up top, and then a person might be an employee, and then a specific employee might be faculty. So our sort of chain looks like this. Our inheritance chain looks like this. Because not every person is a faculty. But at least nowadays, every faculty is a person. Someday I might have robots, right? But for now, every faculty is a person, but every person is not a faculty. So that's how you can think of this sort of sort of general to more specific. So let's start with main, and let's follow through with what happens and get some of the output here. So we start in main, and we create a new faculty. So that brings us up to here. And it has us print faculty, right? No. There's an implicit super call. Every single constructor has a call to super as the first line, even if you don't write it in. Or at least it has if you don't write it in, it has a call to super. Otherwise, you can call this, which is what's going to happen in the next class. So we have an implicit super call that Java added in for us. When we call super with no arguments. Spotlight on. So we call it with no arguments. So where does that go? It goes down here. Employee, our super class with no arguments. Then I call this with a string. That's going to call another constructor within the same class that takes a string, which is this one. Okay, so now we print whatever that string was, right? No. That's another implicit super call. We have a call to super with no arguments. So we do that, and we end up here with person, and we're at the top of our chain, so we print person. So the most general gets set up first. Once we're done with here, we've finished the super call that was here. And so now we're going to print a string and a new line. But what string? Well, it's the string that came in here. It's this string because I called this with this employee S, and that went up to here. So that's the string that gets printed next, employee S. And then we've finished this, which was the call here. So now we're down to this print to print out just employee. Then we finish this one, which finishes the implicit call to super from here, and we print faculty. So person gets set up first, then employee, and then faculty. Now, hopefully, that makes some sense. It's not always easy to get this at the beginning. Whenever you look at a constructor, just assume that there's a call to super. And think about what would happen if you do that call to super. All right. Got another quick little example. This will give you an error. So this will not work properly. So I have this class called apple, and it extends fruit. So we have our fruit here, and apple extends fruit. Be apple. Fruit has a constructor that takes a string. Apple doesn't have any code in it at all. But Java automatically puts stuff in here. So I'm going to go into Eclipse, and I'm going to code this up, and we're going to see what the error looks like. Because I want to point out sort of what Java automatically does for you. So I'm just gonna leave it in the same project here. So I'm just gonna create a quick class called apple, and it's basically gonna be empty. I'm gonna change the extends fruit in just a second, and I'm gonna create a new class called fruit, and fruit is going to have a constructor. So say public fruit, and this is gonna take a string called s, and there doesn't necessarily need to be anything in here, but we can do a print. And we can just print out this string. Okay, so a very simple fruit class. If I take my apple class and I say extends fruit, I immediately get an error. And the error says, implicit superconstructor fruit is undefined for default constructor, must define an explicit constructor. But I don't even have an constructor in here. I got a constructor here, but not here. So what is Java doing that I get this error? Well, clearly I need to call super in some way. And fruit does not have an empty constructor, right? Because if we had a constructor for apple, the first call would be this, which doesn't exist. Fruit does not have a no argument constructor. It takes a string. But we don't have a constructor here, so why do I get this error? Well, technically, we do have a constructor. If you don't include a constructor in a class, Java automatically gives you one. The one it gives you, I'm going to type it up. It gives you this one. It gives you this. That's the constructor Java automatically gives you if you don't include it. But what does that mean? And it also includes the first line has to be a call to super. So Java actually gives you this one. This doesn't work because I don't have a no argument constructor in fruit. So I have to send it a string. Then it will work. So Java does a lot of extra stuff for you in hopes that it will help. But if you're not used to it, or you don't know all of the concepts of what this constructor chaining stuff is, the errors will be quite cryptic. So that's something that I did want to point out in case you notice something like that, or in case you happen to run into that in the future. All right, so here it says, yeah, so this is sort of one of the errors if you were to try to run the program like that in this situation. All right, so let's look at the output of this one. This is a very similar thing as well. It's shorter, sort of smaller than the other ones, but it's very similar. So we have sort of the pen back out here again. So we have a class here that contains main. So it's just a separate class. And then we have this wit class and the CS class that extends wit. So again, it's useful to draw out some of these diagrams. So we have wit, and we have a class CS that extends wit. So it's a very simple diagram. This class here is just used for main, so it prints some stuff out. So let's think about what the output's going to be. So the first thing that happens in main is we print out before. So that's the first thing we do. And then we're going to print out, or we're going to create a new CS object. When we call this new CS object, we're immediately going to go down to this constructor here. So we go to the constructor, but remember, we have an implicit call to super. So super is technically right here. So we go down to super, and we get to wit. So the first thing we print after our before is .wit. Then we finish this constructor, which means we finished super. So now we can print the .cs. And then we finished creating the object. So we come back up to main and we print .after. So that's the order that this stuff prints, because we're going to end up setting up the superclass first before the subclass. So we get the before from here, the wit from this one, CS from this one, and after from this one. So it's just more examples of this constructor chaining idea. So we had that implicit call to super here. So that's our output. So like I said, we will see a lot more of this in our sort of like exam review stuff that we do before we have our first exam. We're going to talk about this kind of stuff. It's all here. All right, so let's go back to PET. Talking about some constructor chaining, that sort of gives you the idea of what's happening with super. In the example that I put in here, I put in that says, right? But we just get the question marks. And that's exactly what we saw here. We saw the question marks. What we don't want question marks. We want woof for a dog and meow for a cat. And I'm actually going to take this apple and fruit and get rid of them. So we'll just delete them. I don't need them. And we'll be back to the dog and cat stuff. Okay. So I don't want to just print out question marks. I want to make sure they print out the appropriate thing. So this is where the idea of overriding methods comes in. Sometimes it's necessary for a subclass to modify a method that's defined in the superclass. So right now, says in the superclass is all question marks, but I want the dog to still be able to use that function, but to say woof. And I want the cat to use the same function, but for it to say meow. So this is method overriding. We're going to create a method in the subclass that has the same name, the same parameters, and the same return type. So the signature is exactly identical. That will do the override. So I'm going to show you how that works. The basic idea then of inheritance, sort of as a whole, is that you inherit what you can. Get name, get ID, the data members, that sort of stuff. You add new things if the class needs them. If the class is a specific class, like a cat that needs to have hairballs, then you do that. And then you modify what's already there. Here I said speak, this should say says. So we can modify says by doing an override. In Java, you're going to see annotations that say override. It's just a form of metadata. You don't actually need them. They're not just for fun though. They're not just like, oh, we can put them in there and do it. They don't have a direct effect on the code, but they're useful for detecting errors for yourself and for telling other people what the code is supposed to be doing or why the code is doing a specific thing. So some of you have seen this suppress warning resource. That's just an annotation. And so it ignores a warning on the scanner, for example. At override, and the annotations will all have ats. At override gives you an error if you are not overriding an existing method. So if you think, oh yeah, I'm going to override this method, and you do this, you write this method, and then you put override on it, and you get an error, then maybe you did something wrong. So it's meant to help you find errors, but it's not actually part of the code itself. Some languages, in order to override a method, use special keywords. So depends on the language, but Java uses some annotations. So I am going to use that. I am going to show you what that looks like right now. So let's go into back to Eclipse. So let's go into dog, and I'm going to override says. So says is public string says. So this has to look exactly the same. Public string says. And then I can put whatever I want in it. So I'm going to put return woof. And a semicolon. Okay, great. Return woof. I don't need to put the at override, but I'm going to do it. I'm going to try to make sure that throughout the semester, I make sure that if we're overriding something, I put in the at override. In Eclipse, it actually puts a little icon in the gutter over here. In the clear over is just right to the left of the line number. And it says overrides pet.says. So Eclipse is actually telling you, hey, this is an override. But I can also put at override. And it'll just be a little note. If I mess something up, then it will show me. Because I could write something like says one, and this gives me an error because the method is not an override, because I put the little tag here. So the tag is meant to help you out. If I get rid of the tag, the error goes away. So if my intent is to override says, and I spelled says wrong, then Java is going to warn me if I put my tag there. So it's an annotation. It's there to help you. All right, so now dog has its own says. So when I go back to main and dog runs says, Java looks in dog first and says, is there a says here? Oh, there is. Use that one. So if we run main, we're going to see the woof now, because I ran dog's version, not the pet version. Cat right now would still run the pet version. So let's write a cat one as well. So I'll put my annotation here at override. And then we're going to do, this will be public string says. And we're going to return meow. Return meow here. Back in main, let's actually change this to a %f. I'm just going to change it to the same thing that dog is doing. And we said we're going to print out the cat and what the cat says. So run here, and there is our, looks like we need another new line here. just to format it. So the cat says meow, the dog says woof, because they overrode the pet says they can each use their own version. There's one more override in this code that we wrote. There's one more method that's actually technically an override. If you look through pet and you look in the gutter, because we saw the gutter here, we saw this little green triangle here that says it overrides. If you look in pet and you scroll down, toString overrides as well. So I could technically put at override as an annotation above toString because it is an override. We'll talk more about why it's an override in the future, what exactly it's overriding. Because from the looks of it, pet doesn't have a superclass. So how can we override something if it doesn't have a superclass? We'll talk about that more in the future. All right, so here's just that info that says, here's the override for the dog. And then the dog would say woof after this. So it's just a little bit of that changes to the code that we wrote. All right, so toString actually comes from object. Every class is a subclass of object. So me writing pet is equivalent to saying public class pet extends object. The two things I just had, this version and the one without the extends object, are equivalent. That's why we have super here as well, because we're calling the super constructor the no argument constructor of object. It's exactly the same. This is what's in there, even though we didn't explicitly write it. And so toString exists in object. This says overrides Java lang object toString. So toString already exists in object, and all it does in object is does get class.getName and ampersand and basically a hash code, which is where the memory location is. So when we write a toString method for a class, we are overriding the base implementation of the object superclass. So we were messing around with some of this stuff even before today. You write a toString, you are overriding a method from object, which is a superclass of every object in Java. So we will talk more about this and more about sort of what this means sort of for us, particularly when it comes to things like polymorphism and stuff like that. So that is all for this lecture. It was a lot. Inheritance is sort of really getting into some of the weeds of object-oriented programming, specifically when we talk about constructor chaining. So we'll do some more inheritance in the next lecture, and we'll start with some polymorphism as well. That gets into even more weeds and sort of ways to program that are a bit complicated. So we will talk about that in the upcoming lectures.